everyone. Welcome back to my YouTube channel Physics with Pavitra. In the second part of motion in one dimension, we are going to look at some of the numericals on distance and displacement. So before going to the numericals, we will just have a quick recap on whatever we have seen in the previous video about distance and displacement. Distance is the total path covered from initial to final position, whereas displacement is the shortest path between the initial and final position. Remember, displacement does not depend on whatever the path which has been taken by the body to reach the final position from the initial position. It is just going to be the shortest distance between the initial and final position. Considering the unit, it is meters for both the distance and displacement, and the dimension is length. Distance is a scalar quantity. It does not depend on direction. It is just the magnitude of how much the body has been traveled from the initial to the final position. Whereas displacement is a vector quantity which depends on the direction. So distance is positive or 0, whereas displacement can be positive, negative or 0. So now we will start solving the problem. So the first problem states that a person travels from point A to B. Now we have to find the distance and displacement. So as we can see, the person is traveling along the arc AB. So how to find the distance? Distance is nothing but this arc length, right? So we know that arc length is going to be radius into the angle subtended, theta. So my distance is nothing but r theta. Now how to find displacement? We know displacement is the shortest distance, shortest path between the initial and final position. What is the shortest path between any two points? It is just the line connecting these 2 points, right? So my displacement is going to be the line AB. So now how to, let us say the length of AB is going to be S, okay? Now my displacement is S. We are supposed to find this S. So to find this S, I am going to drop a perpendicular from point O. So from point O, I am dropping a perpendicular on the line AB. So let this point be my X. Yes. Now this point is my X. Now we are supposed to find the distance S, right? So now we will consider the triangle AOX. So we know we dropped the perpendicular line. So this distance AX is going to be half my AB, right? So this will be S by 2. And also this angle AOX is going to be theta by 2. So considering triangle AOX, I can write my sine theta by 2 to be S by 2 divided by this hypotenuse is nothing but my radius. So it is going to be R. So I can write my S as 2r sine theta by 2. So this is my displacement and this is my distance. Remember, these two formulas are very important while solving problems. So I would like to recommend to always remember this formula. So we can use this formula for various cases. This is a general formula. Now let us understand how to use this formula for various cases. Now let us say my case 1 is in the previous video I have discussed about a problem where a person is walking along a circular park, right? If you remember, a circular park with radius r, and if the person starts from point A, so he makes one complete round and he reaches the same point A. Now in this case, what is my distance? So by using this formula, I know distance is going to be r into theta. In this case, what will be my theta? My point B and point A coincides. So my theta is going to be 2 pi, one full circle, right? So my theta will be 2 pi. So 2 pi into r, which we got the same thing in the previous video also, because he was walking along the circumference of the circle. I directly used the formula 2 pi r. So we can verify that these formulas which we derived are right. And let us find the displacement. Displacement, the formula is 2r sine theta by 2. Here my theta is 2 pi. So 2 pi by 2 will be pi. We know sine pi is 0. So my displacement is going to be 0. Right? Okay. Now we will, I will give you one more case which you will solve to have a better understanding. Let us say this is point B and this is point A. Okay. Okay. I'm telling, okay, this is a curve. Okay. So the person is traveling along this curve AB, and tell me, and this angle is 120 degree. Find the distance and displacement for this case using the formulas which we have derived now. This is a very simple one. I hope you can solve this if you would have understood whatever I have been talking right till now. So after finding the finding the answer, please put your answers in the comment box and let's check whether you understood or not. Okay, now the second question states that a wheel is rotating on the ground. So we have to find the displacement of a point A on the wheel after half rotation. Okay. So this is my wheel which is on the ground, and this wheel is going to rotate on the ground, and there is a point A which is touching the ground at one instant, and after half rotation this point A will reach this point, right? Now we are supposed to find the displacement of the point A. Now if this question is given, as I have observed, most of the students will use this formula 2r sine theta by 2, and since this is a half rotation, the theta is pi, right? So 2r sine pi by 2, which is 2r. So children just say that the displacement will be 2r. But if you are going to do this, the answer is completely wrong. Why is it wrong? This is a circle and I have derived the formula previously and you have applied. Why is it wrong? This is wrong because in the previous case where I told about a circular park, the person was traveling only in the fixed park, like the park is not moving at all, right? The circle is fixed, only the person is moving. He reached this point and again he reached this point, that is he had one full rotation and reached the exactly same position, so the displacement was 0. But in this case the wheel is moving on the ground, right? What as I have already stated, displacement is going to be the shortest distance between the initial and final position. My final position is not over here, no, my final position is here. So what will be my displacement? My displacement is going to be the line which is joining these 2 points, right? This is my displacement. This is my displacement. It is not this line which is joining these 2 points. So how to find displacement in this case? So my displacement is this line. Now to find this displacement, we will consider a triangle. Okay. Consider this triangle. Now from the diagram we can see that this length is going to be 2r, right? But what about this length? Let me name this point as B. So what about the length AB? So if the wheel is going to rotate on the ground and they are stating it is half rotation, so half of the circumference of the wheel is going to touch the ground, right? So this is just nothing but the half of the circumference of this circle, which is nothing but pi r. So using Pythagoras theorem, I can tell my displacement square is going to be equal to 2r whole square plus pi r whole square. So my displacement will be r root 4 plus pi square. So this is my displacement and it is not 2r. Okay. Now we will move on to the next question, which says that a person moves 20 meters south, 20 meter west and 20 root 2 meter towards northeast. Find the distance and displacement. So to solve this question, we need to have a basic knowledge about the directions. So as I have given here, this is the north, this is south, this is east and this is west, and all the directions which are in between the major directions, will be named like this: northeast, southeast, southwest and northwest. And also these directions are going to be 45 degree from the horizontal and also from the vertical. This you have to remember. Okay, now we will solve this question. This question states that the person is starting to move towards the south for 20 meters. So it will look like this. So let's say this is 20 meters, right? And 20 meters towards the west. So this is the point he is starting, and this is A, and he is moving 20 meters in west again. So in this direction he is moving again. This is also 20 meters. Let us name it as B. And they are telling that he is going to move 20 root 2 meter towards the west, northeast. Sorry, he is moving 20 root 2 meters towards northeast. So in which direction is northeast? It is this direction, right? So I have to draw it this way. Now I have drawn the diagram such that the line from B touches O, but it is not necessary that it is touching. Okay, so let's see. Okay, this 20 meter OA and OB will form a right angle triangle with a hypotenuse, right? Now we will find, okay, what will be the hypotenuse. Okay, it will be 20 square plus 20 square, which is going to be 20 root 2. So the person, this is also 20 root 2 and this is also 20 root 2. What we can say, the person is actually reaching his initial position as his final position, right? He is moving 20 meters in the south, 20 meters in the west and 20 root 2 meters in the northeast direction. Actually this 20 root 2 meters is completing the right angle triangle. So this person is actually starting from his initial position and is reaching this initial position as his final position. So what will be my displacement? Displacement is going to be simply 0 because my initial and final positions are same. What about the distance? Distance is going to be simply the sum of all the length of the all the paths, right? So it's going to be 20 in south plus 20 in west plus 20 root 2 in the northeast, which is 40 plus 20 root 2. That is going to be, I will write it here. So my distance is equal to 20 into 2 plus root 2. So this is my distance. Now we will move on to the next question, which says if an object is moving in one dimension, then which of the following is the correct option? Option A tells that my distance is always greater than the magnitude of displacement. Option B tells that the distance is always lesser than the magnitude of the displacement. Then option C tells that distance is greater than or equal to the magnitude of displacement. And option D tells that distance is always equal to the magnitude of displacement. So this is the given question. Now this says the object is moving in one dimension. That means if a person is going to start from here, he is always moving in one line, right? He is always moving in one line. So let's say this person starts from his home and reaches a shop over here, okay, in this direction. Then I can tell in this case my distance will be equal to the magnitude of my displacement, right? But is it always true? What if this person decides to come back to his home again? He will change his direction, right? If he is going to change his direction, then my distance will be 2 times, let's say the distance between home and shop to be L. My distance will become 2L if he changes his direction and reaches back his home, whereas my displacement will become 0. In this case my distance is greater than the magnitude of displacement, right? So I can tell my distance will be equal to the magnitude of displacement when there is no change in direction. When there is no change in direction, whereas my distance will be greater than the displacement magnitude when there is change in direction. Now tell me, is it possible in any case to have my distance to be lesser than my magnitude of displacement? It can never happen, right? My distance can never be lesser than my displacement's magnitude. So this is completely impossible. So my answer is option C. My distance can be greater than or equal to the magnitude of displacement. These two are right, but only at certain cases. My option A and option D are happening only at certain cases. They are not always right. So the answer is option C. Okay. The last question says that an object moves 40 meter in north. Okay. We will draw the diagram alongside. So the object is moving 40 meter in north. Okay. And 20 meter in the east. I'll change the color so that it will be more clearly visible and draw it again. So we are going to have 40 meter in north, and from there it's going to move 20 meter in the east. This is my east, so 20 meter in east. So 20 meter in the east. Okay. And it is saying 40 root 2 meters in the southwest. This is my south and this is my west, so southwest will be like this. So this is going to be 40 root 2 meters. Okay. So this is my diagram. So it looks something like this. This is 40 meters and this is 20 meters and this is 40 root 2 meters. Okay. Now what we are going to do is we are going to first resolve the components of this 40 root 2. So what we will get? So we will be having two components, one along x and one along y, right? So one will be in this direction and the horizontal component will be in this direction. So if I'm going to resolve the components, so this is my 40 root 2 meters and I'm having my components this way. We know that this southwest or northwest, these directions are going to subtend an angle of 45 degrees, right? So this will be 45 degrees. This will be 40 root 2 cos 45 and this will be 40 root 2 sin 45. So cos 45 and sin 45 are 1 by root 2. So the root 2's get cancelled and we get the components to be 40 meters. So we will be having this to be 40 meter and this one also is 40 meter. So this is my final position and this is my initial position, right? So if you look at the components carefully, we observe that this is also 40 meters and this is also 40 meters. So what can we tell? Vertically, there is no displacement in the initial and final position because both of these are in 40 meters only. There is no displacement in the vertical direction. Whereas if you look at the horizontal component, my initial position is here, which is at the origin, and my final position is here. So this length is going to be 40 meters and this length is going to be 20 meters. So I will draw it clearly here. My initial position O, and let's say my final position is A, and this is the origin, and this length is going to be 20 meters, and this length is 40 meters. So what will be this length AO? My AO is going to be my displacement, right? So what is AO? AO is going to be 40 minus 20, which is 20 meters. Therefore, my displacement is 20 meters. In which direction? In this direction, right? So this direction is west. So my displacement is in 20 meters west. So this is the answer. So I hope you would have understood whatever problems we have discussed today. So these are some of the problems from previous JEE paper on the topic distance and displacement. In the next part of the video, we will be discussing about speed and velocity, and also some of the problems related to these concepts from JEE paper. Thank you for watching this video.